Hi, we're going to work with linked lists now, and I'm going to go through using a book that I use for classes. Book is called Problem Solving with Data Structures, and I can show you. Go up here just a little bit. I think it has the name on there. Nope, it doesn't. Yeah, the Problem Solving with Algorithms and Data Structures. So release three. This is an open source book that we got from, or I got off of internet, um, and you can get it as it's in a PDF format. So but it's an old book. It's 2013 is when it was published, but it has some great examples and stuff in here. Now we're going to be working with linked lists. This book calls them lists, and I don't know why they do that. I think the actual Python lists were out by this time, but we're going to call these linked lists. Okay, so that's what we're going to be creating here. And the idea behind this is get down here so you can see this. Well, let's look at and actually they call this an unordered list. And what we're going to be doing is a linked list, and that's what this is here. So these are the different methods that we're going to need in here. List, which will be the init, creates a new list that's empty. A new linked list that's empty. Add lets you add nodes, which will have the data that you want to store, to the linked list. Remove, passing in the add, you pass in an item. The remove, you pass in the item that you want to remove. Let you remove the linked list node that has the item in there. Search lets you look for a specific node that has an item match. Is empty will tell you whether there are any nodes in the linked list. Size returns the number of items or nodes that are in the linked list. Append will let you add an item to the linked list at a particular location based on here based on the actually append adds it to the end of the linked list. Index item returns the position of the item in the linked list. Insert POS item will let you insert an item at the position specified by POS. Pop removes and returns the last item in the list, and pop POS removes and returns the item at position POS. Okay. Now we're not going to do all of those. We'll do quite a few of them, and then we're going to modify this to work with stacks when we get done with this. So implementing a linked list. Here's an example of what they kind of look like. If you had these numbers stored in memory, they could be all over the place. Well, what we do with and if you're doing this with a list, the numbers are going to be in contiguous order in memory. But with a linked list, they can be any place in memory, and they're tied together by the position where they are. So we have a value that starts with, that's pointing to the first location that has a value in there, and we call that a pointer. So it's pointing to the first value. That value then has a pointer that's pointing to the next value, and so on through. So it doesn't matter where they are in memory, those pointers have the address of where the next one is. Now when you get to the last one, its pointer is going to be pointing to the Python keyword none, capital None. So the first thing we need to do is create a node class. This allows you to create a node and then do some manipulations with it. So we're going to get started with that. And what I'm going to do is open up a blank file. Start a new file. There we go. And so we're going to create our node class here. So class node. Okay, so in our init, this is where we're going to pass in our initial data that we want to store into the node. So self.data is going to be equal to our init data. And then our pointer, which we're going to call next, is going to be equal to none because we don't have anything for it to point to right now. Okay, so once we get that done, now we're going to have 4 other methods in our node that allow for the manipulation of this stuff. So we're going to have 2 accessors or getters, whatever you want to call these. So we're going to get our data, and this is just going to return our self.data. And then we're going to get our next, and this is going to return self.next. Then we want our set data, so we want to be able to set our data to a specific value. We're going to call a new data, and self.data is going to be equal to our new data. And then we want to be able to set our next and that's going to be equal to self.next equal to new next. Okay. So that's our node class. I'm going to go ahead and get this saved. And I've got a folder here I'm going to put this in. I've already got node in here, so I'm just going to save over the top of it. Okay, so I was playing around with this earlier before I started this video, so I'll just save over the top of that. Okay, so that's our node class. That's what's going to create our nodes as we go through this. So now what we want to do is actually start creating our linked list class. Okay, so this kind of shows you how this works. Our temp points to the structure for our node, which is our data, and our next, and then next points to none. Okay. And then we put these in there already on there. So and it just shows a little example here of doing that and getting the data at the in the shell to print that out. So they're going to call this an unordered list class. We're going to call this a linked list class. And what we want to do in here is be able to put in all those methods that we talked about in order to manipulate our class here. So be able to add nodes to the class, remove nodes, search for nodes, different things like that. So that's what we're going to work with on here. So let's go ahead and start creating our class here. So let me pull up my one that I had here, my node class here. Okay. And so we're going to create a new file. So first we need to do is from our node class, we're going to import node. Then we're going to create our linked list class. Okay, and so then our init, what we're going to do is we're going to just make self.head equal to none. That's going to be our pointer to the beginning of our class. Okay, we can go back over here. So that's the first part there. Okay. So now what we want to do is check to see if our linked list is empty. So we're going to do another function here. I'm going to call it is empty, and all we have in here is self. And then all we're going to do is return self.head equal none. If self.head is pointing to none, that means that there's nothing in the linked list. Okay. Now our next one, pull this back up here. Okay, so this kind of shows adding these in here. So that's the add part. We're not there yet. Let's see, where are we? We got the is empty. Oh, maybe, yeah, add is the next one here. So this is showing you how to add items to a linked list. So to do this, we create our node. I'm going to call it temp. We then have to take the pointer that's originally pointing to none and have it point to head, what head is pointing to. And then we take head and have it point to the new node that we created. Okay? If there's nothing in there, head's pointing to none, so this wouldn't actually change, but we still have to tell it to do that, so we don't have to do something different on that. Okay, so let's go ahead and start putting the code in for the add. So on the add, we have our self and our item. Item is the value we want to put in our node. So temp is going to be equal to our new node, passing in our item, and then temp dot set next is going to be just self dot head. So we want to set temp's next value to self dot head, and then self dot head we want to make equal to temp. So that goes with this stuff here. Okay, so we make temp dot set next, take its next and set it to head, and then we take head and set it to temp. Okay. Now we're not going to test this out yet. We're going to get the next one in here first, and then we'll do some testing out. So the next one is, there's the add there on there. So the next method we're going to do is all these together here. Size, search, and remove are all based on a technique known as linked list traversal. What that means is it starts at the beginning and goes through one at a time. Now on the size, we want to go through all of them. We want to add one to a counter so we can count how many we have. When it gets to where the node that is on, its next value is equal to none, you're out of them, so you stop. Search works similar. The difference is, though, that we're looking for a specific value in there. So we will search until we find the node that has that particular value. And then the remove is similar to that. We're looking through until we find a particular value, but instead of just saying, hey, we found it, we're going to remove it from the linked list. Okay. So we're going to start off with the size. Okay. So this is kind of show you here on I'm not sure what that's showing you there. This is the traversal that it was talking about. And what we do is we use another pointer called current that starts at head and works its way down. And the reason that we're using another pointer is we can't move head. If we move head, we'll lose the starting point. Okay, so def size, and just passing in self, or as a parameter for that. And we're going to set up our current pointer. It's going to be equal to self.head to start with. Okay. We're going to set our count equal to 0. So now while current does not equal none, we haven't run out of nodes yet, we'll go in here and process this. Count plus equals 1. And then we need to move current equal to current.get next. Move it down to the next node. Once we get done with all that, we're going to return count. Okay. So let's test this out a little bit. Okay, I've got a test program that we'll add some stuff to. I'm going to do a new one here. We can't do everything in here. We just do part of it. So we'll just put in this part that we can do. So from our linked list file that we have out there, we're going to import our linked list class. Okay, so first thing we're going to do, we're going to create our object for our linked list. So my list is going to be equal to linked list. Okay, we're going to see if it's empty, which it should be. So is my list empty? check that out. Then we're going to add a couple of items. Add 93. And we're going to add 56. Then we're just going to print message saying we added 2 numbers. Now what we want to do is we're going to check on the size. Okay, we can't do anything else right now because we don't have anything else in there. So we're just going to print how many nodes. Okay. Whoops. Okay, so then we want to run main on that. So I'm going to go ahead and get this saved. Oh, wait a minute. Well, let me go ahead. I'll go ahead and get this saved here. We're going to save this as test linked list. Oh, misspelled it there. Save. It'll save over the old one that I had in there. Well, actually it didn't, so I must have misspelled it again. So anyway, and then I need to double check and make sure. Nope, I haven't saved my class here yet, so I need to do that. So I'm going to save this as link list.py, lowercase l on the front of it, and then list is as an uppercase L. And this is one that I already had in there, so I'm going to resave over the top of that. Go back to my main program here and run this. And there is my list. Is my list empty? Is true because there's nothing in there. We added the 2 numbers. How many nodes? We have 2 nodes. So everything's working up to this point. So let me pull the okay, let me find the right one here. There we go. Okay, so we're going to go ahead and go to the next one, which is going to be our search. And this one we're going through here and we're looking for a specific the location of it, or to see if a specific value is in here. And we'll just return a true or false if it is or not. So we're going to do a search on self, passing in the item that we want to look for. Again, we're going to use a current pointing to where head's pointing to. We're going to set found equal to false, and then we'll run through a while loop. So while current does not equal none and not found, we'll go through here. If current.getData equals our item, then found equals true. Else we need to move our current forward. So current then is equal to current.getNext. Okay. Once we run through there, eventually it'll fall out because current equals none, or we found what we were looking for. So then we just return found. It'll either be true or false, or whether we found it or not. Okay. So let's test this out. Go ahead and get this saved. Go back to my program here. So we got 2 items in there, 93 and 56. So now we can do this. We can print is 93 in my list. And then so we can just do my list dot search for 93. And then we'll print, I'm going to do another one, is 44 in my list. And then do my list dot search for 44. Okay, so let's run this. See if I got any errors in here. I always like doing these testings a little bit at a time. But there we go. 93 is in my list, and 44 is not in my list. So that worked out great on there. So, okay, so let's go back to our linked list here. And what we're going to do now is, instead of running back and forth to the other thing there, we're going to just go ahead and continue on here because they're all about the same. They're just a little bit different. We're going to do a remove. And with this one, self.item. And so again, we need current, and it's going to be equal to self.head, but we're going to need another one also. Previous is going to be equal to none to start off with, okay? And the reason for this is, let me get to the book over here. We'll go down here to the remove. The remove is going to be a little bit longer than just doing the search to find a number. There's the search. So in order to remove the node containing the item, we need to modify the link in the previous node so that it refers to the node that comes after current. That's why we need two. With current, we're on the one we need, but we need to look at the one before it, and we can't go backwards. Okay, so we bring two through. Current is pointing to a node, and then previous is coming up behind it. So once we find the node we need, previous is on the one behind it. So now we can take previous, change its pointer to point to the one around it, one the current is pointing to, which then removes it from our list. Okay, so that's what we're going to do with that. Okay, so previous equals none. Found is going to be equal to false. So then, while not, whoops. So while not found, if current dot get data equals our item, then found equals true. Else previous equals current. So we can move it up one, and then we need to move current up one. So current equals current dot get next. So we move it to the one before current is pointing to. So now if previous equals none, that means we never moved current, so we never moved previous. So they're both still pointing at the one that head's pointing to. That's the first one. So self.head is what we're going to move here, is going to be equal to current dot get next to move around current. Current's pointing to the first one. Previous is pointing to the first one. Okay. So else previous is going to be equal to set next to current dot get next. So what that's going to do then is previous, the one the previous is pointing to, is going to go around the next one that's in there the current's pointing to, and point to the one after current. So current dot get next. So that node now is no longer pointing to anything in there, and it's just lost. And what it will do at that point is the garbage collector in the software will clean up the memory on that, and it will be used for something else at another point. One of the things that you need to know about this is that this is assuming the item you're looking for is already in the linked list. So before you run this one, you might want to run the search first and make sure it's there. And if it's there, then run the remove to remove it. Okay, otherwise, you need to modify this to where if the item isn't found, then you send back a message saying that the item's not there. So something has to be done that way on this one here to do that. So let's go ahead and we're going to put in another method at this point. We're going to call it print list. So we can print out all the nodes that we have in here. So current is going to be equal to self.head. So now while current is not equal none, we'll run through this and print them out. We're going to print current, print current dot get data. And we're going to do an end equals quote space quote in there, so we have a space in there after that and not go down to the next line. And then current equals current dot get next. And then after we get done with this, we'll print a blank line to go down to the next line on there. Okay. So now let's go ahead and do some testing on this. Go ahead and save this. And I'll go back to our main code here and we'll modify this a little bit. So I've got that in there. We added those two lines. Now right here after this, we're going to do a print, my list dot print list there. Then how many? I'm going to leave these two in here. Actually, I'll change the wording on it so it matches up to my stuff here. Find 93. And then on this one here, I'm going to do a find 100. There's 93. Okay, and we'll put 100 in here. Okay. Now let's add a couple more items to this. And we'll add 17. And then we'll add 34. Okay. We're going to print two more numbers. My list dot print list, and then we'll do another print here. How many nodes? My list dot size. And then we'll remove a number here because we got the remove. Let's see. Let me double check. No, we haven't put. Yeah, we did put remove in there, so we got remove in there, so we're fine on that. Just want to make sure here. And so on this one, then we're going to do a my list dot remove, and we're going to remove 56, which is right up here. Okay. And then we're going to print removed 56 my list dot print list. And then we're going to do how many nodes. So I'm just going to do a copy this and paste it in down here. Okay, so let's test all this out. Whoops, crashed there. How many nodes? Let's see what we crashed on. Oh, we crashed on our removed. I wonder if I didn't save that. Nope, I did save it. So let me see where my error is. If current.getData equal item node object has no, oh, I left an A out there. See that? Okay. There. Current.get data. We'll save this and run it again. See if I have any other errors in here. Yep. Let me see what I did wrong in there. That was a previous dot set next. Let's see where that's located. My list dot remove 56. Yep, I gotta find the right file here. Okay, so it's right in here. I think that's supposed to be previous dot previous dot set next, not equals. Okay, I do that every once in a while. So this one here, I need to go ahead and save it again, and then run this one again here. And there we go. So my list, is my list empty? Is true. We added two numbers, 56 and 93. How many nodes? We had 2. Find 93 was true. Find 100 was false. Okay. We added 2 more numbers, added more numbers. I don't know what the none is there. I have to look and see, but there's the other 2 that we added in there. How many nodes? 4. We removed an item, 56. And how many nodes? 3. And I think these nones are coming up because in our remove, it doesn't return a value, but we have it, let me get over here. Okay, I'm gonna put these side by side so we can look at them and I can see what I'm doing on here. So here, added more numbers. My list.print list, and it doesn't seem to like that. On there. Because notice here, my list.print list up here, printed out fine. But when we get down here, we do added more numbers, none, and then how many nodes. So my guess is it doesn't like this inside here. So what I'm going to do is I'm going to take this out of here. And then print it out there. And I think that will clear this up. Do the same thing with this one. And we'll run this again. Yep, see, it took that out of there. So added more numbers. How many nodes? 4. Remove 56. Shows you that without the 56 in there. How many nodes? 3. Okay. So everything seems to be working okay. So I'm going to go ahead and stop here. And if you want to continue on with this in my next video, we'll be looking at how to use a linked list in a stack rather than using a list. Okay. So stay tuned on that if you want to see that one. Okay. Bye.